So, my name is Madeline Snow, and I am with the UMass Lowell. And can I ask you, can you see the PowerPoint or just a weird screen?
I can see it.
You can
We
see
can
it?
see it, but it's not in presentation mode. We see all your slides on the left.
Oh,
I see a bagel.
the bagel's the most important thing. I'm going to try a new share. How's that? All right. So embarrassing. There we go.
Do you want me to let people into the waiting room, Madeline?
Please do.
Yeah.
Please do. That would be great. All right. Can everybody see this now? Oh.
Yes.
Oh, my goodness. Anyway, welcome again. This is the second webinar in a series, sort of the third Friday of each month. And it's for food and beverage businesses. And we are focusing on a variety of ways to reduce costs, increase environmental performance, et cetera. And I want to thank the Toxics Use Reduction Institute and EPA Region 1, and as always, UMass Amherst for their support for this series and their willingness to participate and present. And these are the series that we have. So the next one will be about waste. Bagels are my favorite food next to Lindt chocolate, so that's why they're here. And one of the questions about cleaning, sanitizing, and disinfecting is, do you know what products you use right now? Do you know how much labor is involved in cleaning, sanitizing, and disinfection? How do you store it? How do you handle it? How do you train people? And what are the costs if you don't do it right? So these are some of the reasons that we're putting on this webinar. And just for a review of the pollution prevention hierarchy, because this work is funded under a pollution prevention grant from EPA Region 1. And the concept is that you first try to reduce the source, you recycle, energy treatment, and then disposal as your least preferable. And I will say I worked 20 years on state and federal Superfund sites, waste site cleanup sites. And I will tell you that the money and time that we spent after the fact was just tremendous. And if only there had been a pollution prevention source reduction mindset way back then, it would have been a lot healthier, a lot cheaper, and a lot safer. And again, one of our perspectives, or my perspective, is that pollution prevention really is a business strategy, particularly in these challenging times. I'm going to give you my takeaways right now. You see bagels and Lindt chocolate all in one screen. I'm in heaven. Understanding the difference between cleaning, sanitizing, and disinfection, and why does that matter? Like one of the takeaways is to understand the importance of cleaning and not just throwing chemicals around. One of the other takeaways is one of the themes is to ask questions rather than just accept the status quo. Pay attention to the interplay of practices, chemicals, and temperature, and look for safer alternatives and/or the potential to use less chemicals, reduce and avoid costs. So I'd like to do a quick little scenario here called Joe Knows. And Joe knows, and maybe some of you are those Joes, I don't know. But Joe's been in charge of cleaning at Food Company A for 20 years. And only Joe knows what products he orders and uses for a variety of purposes and locations. And before COVID-19, he was rarely asked about his work. Nobody really, not that they didn't care, but everything was fine, working on. And he's been ordering from the same vendor for 10 years. And only Joe knows what he orders and where he stores those products. And when asked what procedures he uses in his work, he points to his head and he says, "It's all up here." Does this sound familiar? Does this resonate with anybody? Or maybe not in your company, but in a company that maybe you've heard of, or perhaps used to work for. If it does, just unmute yourself and say yes or no, whatever.
Yep.
Yep, okay. And I'm not implying that this is happening across the board. And I'm not saying that it's happening in your companies, but it has been, this does happen. Okay, so now Joe actually hits the lottery and decides that he's going to leave the company and actually gives 2 weeks notice. In the real company that I know of, the guy didn't even show up on the Monday. He hit the lottery on Saturday, $40 million, and went away. And again, what might be some pollution prevention opportunities in this company? And you can just unmute yourself and add from anyone. Where might you look? Oops. Well, here are some hints. You might want to find out who the vendor is and the quantities of what's being used, how it's being used. Are there any safer alternatives? And one of the questions always is about what SOPs actually exist, what needs to be documented. And in the case that I'm thinking about, there were 2 cases. When Joe left, the company had to recreate and find out and actually just reinvent what was happening because they didn't really know. What I'd like to do now is do a short video about an experience by Merrimack Ales in Lowell, Massachusetts. And Adam Pearson will then talk a little bit more about his motivation in some of this work. And you can ask Adam directly any other questions that you might have about why he was looking at cleaning and sanitizing and why he was looking at alternatives. Okay, and that, let's see. Here comes Merrimack Ales, we hope. And are you seeing this one?
Practices, if you think about it coming out of the
No.
No. So one moment, please. I really did practice, I promise.
It always works that way.
I know. And we talked about this. It's a 3-minute video and it takes 5 minutes to get it right. So yeah.
I hear you.
Here we go.
the big guys, Bud, Miller, Coors. Everybody small has paid attention to how they clean, how they sanitize. That's often merged with how homebrewers do things because that's where a lot of us came from. The traditional process, for me as an engineer, is kind of scary. The actual traditional cleaning process uses lye, or sodium hydroxide, caustic, at 160 to 180 degrees Fahrenheit. And it goes in and you spray it around in the tanks and it cleans the stuff off. It descales the tank. You do an acid rinse, and I looked into that, and it's a mix of nitric and phosphoric acids, but it's not healthy. What we have found out by testing all of this with the Tory folks through all this work, I've eliminated any chance of using hot caustic. We found out that we can use the brewer's wash at a lower temperature with same effectiveness. We did follow-on lab tests to show bacteria counts that showed that the sanitizing process using these tabs showed 0 bacteria in the cultures. So good correlation between the ATP floor reading and lab results. We also brewed beer, we tested the beer, and the beer tastes fine. So we now have a good improved sanitizing process. The safety is gotten better all the way through. So in the front tank here, fermenter number 1, we've just finished out fermentation of our pumpkin ale. And this morning we transferred it down to secondary. So this morning after transfer, we have done a rinse down with a hose to get rid of the gross debris and have just started the beginnings of the CIP process. We've mixed up a PBW solution inside. We're running it through the recirculating pump. After that, we're going to do a rinse step to get rid of that, drain that off. And then we're going to mix up the sanitizing solution with the brew tabs. At that point, we'll load that solution in, recirc that for 5 minutes. We'll drain that out because it is a chlorinated sanitizer. And then we're going to do a 2-minute water flushing rinse, at which point we'll pop the manway open and do a swab and get an ATP meter reading. What I hope for that everybody else is going to look at, they're going to be faced with the same decision tree that I was when I started the brewery. Is out of all the stuff that you have to worry about and make decisions on, you want to minimize that. So if you put your cleaning process in place, you want to have a very high degree of confidence that it's effective and it's safe. Safe for your team, safe for the environment. Knowing that this worked, that we learned a lot, that we've been able to put a repeatable process in place that enhances employee safety, guarantees product quality, and is better downstream for effluent and the environment. I want them to know that just because for decades and decades everybody used caustic and acid doesn't mean it's the most effective and you don't have to keep using it. You have a good alternative.
Thank you, Adam. So Adam, could you unmute yourself and talk a little bit
My
about,
name is Pamela Ice, and I'm the training manager at the Massachusetts Toxics Use Reduction Institute. Our work at Turry focuses on helping make Massachusetts.
sorry, there we go. And
Make that stop.
I'm trying. Well, Pam from Turi is on. Very nice. Adam, can you tell us a little bit about why you started this? And then we'll just open it up and questions that people might have for you.
Yeah, sure. It happened very early on. I think the first time Pam and Joy came by the brewery, we didn't even have the tanks hooked up yet. So it, very much from the beginning, as we built this up, they came in with a viewpoint or the desire to make sure that breweries had options for cleaning and sanitizing that would be friendlier to the environment. For me, my main concern was employee safety. We're a little bitty team, and honestly, if I or any of my employees really got injured, that could have really changed whether or not the business was going to work. So together, we came up with something that was safer and better on both sides. You're still on mute, Madeline.
That's good. Does anybody have any questions for Adam?
Yes, Adam, what were the soaps that you used? You're not using caustic and acid rinse. What are you using?
We use, so the main product, if you don't want to use caustic, is something that's in the industry known as PBW or powdered brewer's wash. It's a non-caustic alkaline salt that it's high foaming, good descaling detergent. It's sort of the go-to chemical for the brewing industry outside of caustic. Through the work that we did with the Turi office, we, just by digging around, found some competing brands to the main one out there that initially was a 40% cost savings for the same effective result.
Thank you.
Can you also talk about, Adam, how in that exploration you discovered that you could potentially use less?
Yes. I mean, I don't want to say manufacturers might tell you to use more than you absolutely need since they're the ones responsible for moving product, but you know, it could happen. We tested early on with Joy and a couple of other vendors. We were looking at some of different cleaning approaches like electrochemical activation, splitting it into detergent and sanitizer. And through that sort of experimental array, we tested different concentrations, different temperature ranges, and ended up with being able to get a very good result cleaning the tanks with the low end of the suggested use for the powdered material. And we routinely run it at 150 Fahrenheit. I mean, that's still still hot enough to do damage, but it's better than 180. Came up with a couple of different, what I'll say, SOPs, depending on where in our process you're doing the cleaning and how gunked up it is. The tank that you saw in the video was really not bad at all. Some of them after a 2-week fermentation are a lot more challenging.
I have two questions that have come in through the chat, Adam. One is, have you been able to reduce the use of water, the volume of water that you've been using?
Yeah, we actually, water use per barrel of finished product was one of my, I guess, one of my KPIs of curiosity starting the brewery. The recommended level, I guess, to cost it out when you were still on paper was basically a 9-to-1, so 9 gallons of water per gallon of finished beer. At the time, from what I was able to find out, best in class was around 4. There you want to think about places like Sierra Nevada. So it's been one of the things I pester my staff about all the way through. And we've been able to optimize how much solution we use, the rinse cycle and all that. So we're somewhere in around the 5-6 range, which for our size and everything, I'm okay with. We can always be better, but right now it works.
We just have one more question and then we'll move to Jason Marshall. What was the hardest part of the change? Are there other processes where you're looking for safer alternatives as well? But what was the hardest part of making this effort?
For us, there were really 2. One is by far the hardest is cultural. There's a lot of cultural inertia in commercial brewing, and no one thinks twice about running a hot caustic followed by an acid rinse followed by whatever sanitizer they're going to use, because that's how we've always done it. My engineering background and experience, I have fought the whole "this is how we've always done it" mentality for 35 years now. But getting even not very experienced brewers and cellarmen to trust me that my knowledge of engineering and chemistry were going to take us someplace good instead of what they had heard talking to other brewers. There's a pretty big hump to overcome.
Thank you very much, Adam. And is it true, I went to a brewers meeting once and they were all talking about everyone has scars around their ankles from the acid.
Oh yeah, that's one of the not good things about this industry. There's a strong bro kind of culture, and if you don't have your battle scars, you're not a real brewer. My experience with that wasn't in brewing; it was in an iron foundry, where a guy that was on light duty with us in the lab had his boot filled with molten iron, and I got to see his leg. So that was where I came at it with the whole safety thing. Was I did not want me or my employees to incur 2nd, 3rd degree caustic burns. So a lot of opportunity in the industry for additional safety there.
I am going to move. Thank you so much, Anna. I'm going to move to Jason. We are going to be keeping the Zoom room open for additional questions and discussion at 2 o'clock. It won't be recorded, and so there'll be a little bit more time for some more in-depth questions as well. So Jason from Toxic Use Reduction Institute, I'm going to hand it over to you.
All right. So bear with me. Today is National Talk Like Yoda Day. So I went back through my slides and tried to incorporate some of that to make this a little more entertaining. So before disinfecting, clean you must. All right, that's the talk I was asked to deliver to you guys, talking about cleaning and disinfecting. It's also, think before you do. So the green cleaning evolution, it was hit or miss if they worked, 15, 20 years ago, which created the path to the dark side for the green products. And today persists, it still does. But the good news is that these greener products that are on the market now are no longer inferior to in performance. They work as well as the products you can find on the market that have been out there for years. And what you need to do is you need to make sure you have to test your products. Otherwise, you're going to have products that may not necessarily work for your situations. In the case of Adam, he went through several iterations to find the right alternative for him to switch to, even though they all said, yes, this could be used for your application. He had to find the right one for what he was doing. And that's something that the Terry Lab can do both in the field as well in the lab setting. So cleaning, sanitizing, disinfecting, difference there is. They are not the same, even though some people may interchange them for one meaning for another. The main thing up front is cleaning. You're removing the dirt from the surface. This also is important when you're talking about organisms on the surface, microorganisms, because it helps remove the nutrients that they can grow from, as well as it eliminates places for these to hide or get, be behind a protective barrier, so it's harder to get these disinfectants to work. Sanitizing is something you would follow cleaning with, and it's mainly around bacteria. It does not have viruses or fungi that it can kill, whereas disinfecting is the next level, and it's killing off all forms of the microbial life, the bacteria, the viruses, but it does not necessarily affect the spores. That would be sterilization. That's the next level from there. So the main thing you want to take away from today is you cannot disinfect a dirty surface. And to help illustrate that, I pulled out a video that my son and I worked on as part of our Black Belt Karate community service project last year during the pandemic around disinfecting. Sad news.
Just before you can disinfect it, because the soils can hide the virus from the disinfectant chemicals. Let's take a look. Here's a dirty surface. What happens when we put the disinfectant into the solution and trying to kill the virus? As you can see, the virus is blocked by the dirt and cannot reach the cell. Well, let's wash the surface first using soap and water. So now that the virus is exposed, we bring in the disinfectant chemicals, and as you can see, they disrupt the cell, render the virus inactive.
Hold on a second. Of course, CVS has to call right in the middle of it. All right. So there are alternatives that are out there, and where can you find them? Well, the best way to make sure you're finding products that are, verifiably greener and effective is working with the third-party certifiers that are out there. They help to, give you a level of confidence that what you're looking at is something that has been looked at to prove that it is safer as well as working. The big three that are out there is Green Seal, EPA, with their safer choice for cleaning applications, and then more for the disinfection side, it's the design for the environment. And you also have EcoLogo. In Massachusetts and other states, you can work together with state purchasing to be able to get bigger bang for your buck. Massachusetts has done a great job of identifying safer cleaning products for the janitorial sector, and also looking at disinfectant chemicals as well. So it may not be applicable to your state, our list, but it can give you an idea what criteria they went through to find safer alternatives. For disinfecting chemicals, EPA's Design for the Environment has an authorized antimicrobial list. And what they've done is they go through and they look at several aspects of the chemical as well as the product formulation to make sure that you're using the least hazardous class, either category 3 or 4 for acute exposure. It also is looking at long-term exposure as well as going beyond just the active ingredients, but also looking at the full product and all the inert ingredients that are in there as well. They take the formulation for this disinfectant and they run it through their safer choice endpoints for health and safety to make sure that this overall product is going to be safe for people to be using in the environment that they're working with. They're promoting products that don't require personal protection equipment. That's not to say that you shouldn't be using them, but it's not required. So it tends to be a safer product for you to be looking at. And there's also no unresolved issues around adverse reactions or effects. Does it work in every situation? Is there any kind of regulatory compliance or non-compliance around some aspect of the chemical and how it's being used? They also allow for products with identical formulations, meaning someone has subleased their formulation to somebody else. That is also an acceptable antimicrobial product that you can choose from. Matters how you clean it, it does. So again, the operating conditions that you're looking at is very important to make sure things are working. Are you using the right concentration? Is the temperature the right area you need to be in? Are you using the right kind of mechanical agitation or scrubbing or spray washing? And can it be done in the time frame that you have available? It's important to make sure, you know, you're asking questions as to why. And the answer shouldn't be always done it, we have. And if you hear that, go running for the doors, start over. You ask that question, well, why have you been doing it this way for 30 years? And why can't we try something else? And what if we did this? It's always good to get an outside opinion that someone may not be entrenched in this process to say, hey, let's have someone from the outside come take a look, get a new perspective on what you're doing and figuring out the best way that you can identify possible new alternatives. Thinking outside the box is never a bad idea when it comes to pollution prevention. It's great to think of new ways to do this. The Terry Light is around to help answer some of these questions around cleaning and disinfecting. So please feel free to reach out and ask questions. So part of the push last year was around, well, what can I disinfect with that would be effective for, you know, the SARS-CoV-2 virus? You know, the EPA went through and they have their active ingredients, which we had talked about before. You can see them on the page here. There's also more than just the chemistry that you can use that can be effective on removing the SARS-CoV-2 or any other kind of microorganisms. And I have a list over here of methods and as well as active ingredients. You have dry steam vapor, hypochlorous acid, either through electrolyzed water or through tablets, which was Adam had shown using. There's also aqueous ozone, UVC light, and in some instances, you know, you can use all-purpose cleaners to get the job done. Now, EPA doesn't regulate devices the same way they do with disinfectant chemicals. It's still important to demonstrate that the product can destroy the bacteria or the virus, but it doesn't do it in a chemical way, it does it in a physical way, either through electricity or light, or mechanics, or with heat. I provide a link here for more resources on what they require the vendors to tell you about their product lines. They're regulated to prevent defaults or misleading claims. So most of these companies that are saying, well, my device works well on this, they have laboratory data that shows that they've run it and it can consistently get to the level of disinfection or sanitization that they need to achieve. So they just can't come out and say, yeah, our product works great, go ahead and use it. There is some science behind these companies and their claims. I'm just going to go quickly through some of these. The top of the list is, you know, that I usually like to talk about is the superheated steam vapor device. Now, this isn't your run-of-the-mill steam cleaner that you would use on a carpet where there's tons of water going everywhere. These are low moisture, high temperature kind of situation where you're using these are ones that you can use on a wide range of surfaces, either from porous to non-porous. And the good thing with these devices is that their contact time is relatively short. I mean, it's pretty short. For similar virus to the SARS-CoV-2, they were getting, you know, 4-log reduction, 99.99% kill rate in under 10 seconds. Now, you can imagine trying to use a chemical cleaner, you know, on the bottles, they'll say for a successful disinfection, you need to let this sit on the surface for 10 to 15 minutes. So 10, 15 minutes versus 10 seconds, it's a drastic difference in how well these would work. And it has a wide range of bacteria and organisms that it can be used on. The nice thing about these steam vapor units is that they also work well at cleaning the surface in addition to just doing the disinfecting. So it's a kind of a multi-use device. The next one on the list is hypochlorous acid, which is one of the 3 main chlorinated disinfectants that you'll find people talking about. You have chlorine, you have hypochlorous acid, and you have hypochlorite, which is what is the active ingredient in bleach. They are all 3 can exist in one product formulation depending on the pH that you're being exposed to. The hypochlorous acid, its sweet spot is between 4 and 6, and that's where you can see on the chart that most of what's there is going to be the hypochlorous acid. This is important because the other 2 ends of the spectrum are known asthmagens and can cause health effects to the people that are using these products. So it's It's nice that there's something that can work as well, if not better, in most situations and be safer. What happens in the electrolyzed water system is that water and salt get subjected to an electrical charge, and it basically separates it into the ions, and then they reform, creating hypochlorous acid. And this is your active ingredient in the solution. Like I had said before, getting the pH just right will help ensure that you have the right active ingredient to ensure safety of your workers and the people around it. Some of these devices will add in an acid, and most cases it's a vinegar to help get the pH in the right location. Here are some examples of the ones that people may have seen in the past year or so that you can use for in-home as well as more industrial size. You can see the mixture of salt and vinegar, or just salt. We've been evaluating all these for performance around how well it works on bacteria that simulated the SARS-CoV-2 virus. So we were using the bacteriophage to be able to test these out on and show how well they work. Most of these were being found to be effective within 30 seconds to 1 minute of contact time. And the pHs ranged from 4.5 to 10, depending on which system you were looking at. So you may ask yourself, why is this not on EPA's Design for the Environment list? Well, there were some unresolved compliance enforcement actions associated with it, and it all revolves around the drinking water treatment process. So if you have the large surface water, there's organic matter that's in there. When the chlorine comes in contact with it, doesn't matter which form of it is, you're going to get these byproducts that form, and they have potential cancer-causing capabilities. And so that's the area of concern around hypochlorous acid, because it is the chlorinated disinfectant. But if you think about the overall system, when you're generating these solutions in your in-home device, this organic matter may not necessarily be present in the water. And would you form these THMs in tap water in your kitchen or your bathroom? The one thing that the Turi Lab is looking at right now is what happens if you are using these chlorinated disinfectants, and can you develop these byproducts when you're treating a uncleaned surface to try to disinfect it? Is the organic matter that's on that surface enough to create these THMs, and at what level are they going to be developed or formed? So that's an area that we're looking into right now. Another option that's out there is aqueous ozone. Where you have a device similar to the electrolyzed water, you create a current and you separate the oxygen in the water, and you form the ozone, which then attacks the organisms and soils and then reverts back to being just oxygen afterwards. We are looking at what's the potential for the ozone exposure during the generation and use of these products. Because there is concern around ozone, the gaseous ozone, and what happens with the ozone in the water is that it escaping out into the air that people are working around us. So there's a few devices we came across looking out there. There are low end concentrations for all of them. You can see it's all under 3 parts per million. The Anozo is one that's certified by Green Seal, not for disinfecting, but for cleaning. So it kind of gives you an idea of, they've gone through the process of having their product evaluated by the third party to show that it is safer to be used. UV light is another one that's been used for many years. You have to have the right kind of light for the right amount of time. The UVC is the more prevalent one that people are using, and it has been shown to be very effective on several similar like viruses or harder to kill viruses than SARS-CoV-2. So this is what it does is it causes lesions in DNA and RNA, and this is why it's effective on these organisms, but it's also something to be concerned about exposure to the workers, because we have DNA and these things can happen to us as well if you're exposed for too long. As I had mentioned before, that there are all-purpose cleaning products because of the nature of the SARS-CoV-2 having the lipid layer, which is a fatty layer. Can these aqueous-based products work at dissolving that layer and rendering the virus inactive? We've done some preliminary testing and showing that, yes, you can get some reduction with just using the chemistry and no mechanical scrubbing or anything like that. it's not as effective, but sometimes you may not need to have it completely destroy everything in the surface. You might be able to get this lower effectiveness, might be just enough for the application that you're looking at. There are other ways, many ways that you can apply these disinfectants. But I want to reiterate again, is you still have to use these as directed. Safety still matters. You still have to clean first, use the right concentration and contact time and your personal protection equipment. The different ways that you use a disinfectant can affect the safety exposure and other aspects of using these chemicals. They may not have been validated for performance under these delivery. In some cases, you may not have enough solution on the surface to maintain it being wet and being effective at killing off the bacteria or the virus. So it's important to make sure that the product you're looking at and the method that you're looking to use have been approved for that chemistry. For the electrostatic sprayers, they create a charge on the particles. They can stick to the surface. It helps to reduce the amount of chemistry you use. However, again, this may not necessarily be a good thing. If you get down too low, you may not have enough solution on there to stay wet long enough to inactivate the virus. And you'll also have to, again, make sure you're cleaning the surface beforehand. It's the benefit of this one is you don't necessarily have to have line of sight for it to be effective for coating the surface. Whereas with the foggers and misters, these ones rely upon gravity to disperse and coat a surface. And so the difference between foggers and misters is not much in the equipment that's different. Usually you can find a mister fogger, not to be confused with Mr. Coffee, but the mister and foggers, they're usually one device, and it's basically just a control dial that you can set the droplet size. As you can see, foggers have a 10 micron size around there, and the misters are much larger, around 200 microns. To put that in perspective, you can see the 200 range is a fine drizzle versus a heavy rain or a light rain. There's a significant difference in size. You go all the way down to the fine mist, you can see that these are smaller. Once they get smaller, the issue comes up that these can now also be breathed in easier by the workers if they're not wearing their proper PPE. Again, pre-cleaning is always important. Making sure that your product has been approved for this, and the space of that you're trying to use these devices in, is the air movement going to cause problems? Is the relative humidity too high or too low? Are you having the right kind of contact time? So viruses, the question we always get asked is, do I have to disinfect, and do I have to disinfect all the time? You know, the virus has a limited lifespan on surfaces, as do most organisms. You can see here for the SARS-CoV-2, they had done testing early on to show that within 2 or 3 days, most of what's on that surface is going to be inactive and no longer be able to be infecting anybody. So therefore, if you have an unoccupied space, you wouldn't have to necessarily disinfect that room to kill off the virus. If someone was in there, you can let it sit for 3 days, and you go and do a cleaning, you're probably going down to a safe level. So disinfecting a space all the time is definitely not practical. Shifting gears slightly to kind of touch on the whole pollution prevention triangle, reducing at the source versus treatment. Why is one better than the other? So I just want to kind of quickly go through a scenario of, we're looking at a dirty surface and how much can be transferred from that surface to inside your body to make you sick. So to do this kind of quick calculation, I did some research to finding out what the transference rates were from a non-porous surface by touching your hand, and it ranged between 5% transference up to 22%. And then now you have this on your hand, how much is actually then redeposited if you touch your eyes, your mouth, your nose? How much kind of transfers from there? Again, a 10% is a worst case kind of scenario type of deal. And then for cleaning control measures, what if we were only effective at cleaning the surface, to a 90% level? And how well do we actually wash our hands? The numbers that were out there, people saying, 77% for hand washing, 90% for the surface washing. What this all boils down to is, if, say you have a worst case scenario where you have 1 million virus organisms on the surface. And so if you take the worst case scenario, you go and you touch that surface with your hand, you now have transferred 22% of what's on that surface to your hand. Now, I don't know about you, that's still kind of scary with 220,000 organisms now on your hand. Now you go and you touch your face, you're down to 22,000. The good news is, that's a 98% reduction. Bad news is, good enough, it is not. So now we introduce further up that chain of that triangles. Now, what if we washed our hands? Again, we said use the 77% reduction and then the transference rate. So just by washing our hands alone, we've gone to 99.5% reduction. And we still have yet to do anything to the surface. So if you introduced the 90% effective cleaning and the same, washing your hands and the transference rates, now you're down to you're up to a 4-log reduction. And you haven't touched a disinfectant chemical. So that's kind of why I said before, some of these all-purpose cleaners might be enough to get you to the level where you have, 4-log reduction is pretty significant. If you were to do a minimal amount of disinfection, say a 3-log reduction of that surface, and everything else stays the same, you're now down to a 6-log reduction. What that really means is you've gone from the million viruses on that surface down to 1 organism possibly being transferred inside of you. Is that enough to make you sick? That's the question that people still are trying to figure out. Where is that cutoff saying you need to get to this level? But you can see the importance of being able to clean up front versus down the road, how well you can remove the hazards by doing a systematic approach to your cleaning and disinfecting. What does this? So the good news is most of the surfaces that you come in contact with are not going to have a million viral organisms on it. That, like I said, worst case scenario, that was the number we went with. Also, the virus starts to break down on the surface over time. So if it's an hour after that someone sneezed on that surface or coughed on the surface and caused the virus to be there, they're going to die off before you come around and touch it. So it may not be a million by the time you come by, and then it just makes the scenario less scary. You can achieve reduction of this virus from the surfaces without the need of over disinfecting and using more harsh chemicals to do this. Disinfecting a dirty surface, you cannot. You clean first, you must. Disinfect safely, you can. And that is my final message. And I found one of Yoda's more applicable quotes: always pass on what you have learned.
Thank you so much, Jason. What I am going to do. Huh?
Welcome, you are.
When you said you would change the presentation, I didn't quite get it literally, but it was wonderful. Thank you. I'd like to actually move on to Joy Onash, who's going to give us some other case studies. I am very interested in your experiences, and so if you would like to put them in the chat or wait until she's completed, and then we'll have questions and answers and additional sharing. Thank you, Joy.
Sure, my screen is shared, yes? Okay, and just so you know, speak like Yoda, I do not. So thank you, Madeline. I am the Business and Industry Program Manager at the Toxics Use Reduction Institute. We have been involved with helping the food and beverage sector, specifically in Massachusetts, but also throughout New England and across the nation, in reducing the use of toxic chemicals for cleaning and sanitizing in the food and beverage sector. So just to revisit, I'm sure those of you in the industry or in the sectors are aware of the reasons why chemicals are used in the food and beverage sector to deal with those ingredient residuals and the biofilm buildup that need to be removed from equipment and surfaces, any adulteration that might occur in the process, allergens that you need to deal with, and of course, food safety. And commonly used chemicals, phosphoric acid, potassium hydroxide, sodium hydroxide, and others that have been mentioned by both Adam and Jason. And this goes to Madeline's point on what she would like folks to take away from these presentations today. I just want to reiterate the toxic use reduction opportunities that may exist for you at your facility or facilities that you work with as a pollution prevention provider. By having you look at your cleaning and sanitizing process, understanding the SOPs that you have in place, making sure people know who's purchasing what and how they're using it. and asking questions about why it's done to the amount that it is, for example, and used on the surfaces that they're used on. So also looking at those surfaces as well as the clean in place processes, and investigating the soils that are being cleaned off, the surfaces, what type of substrate it is you're dealing with, the process that you're using to clean and sanitize, as well as those chemicals that we've mentioned. So always asking questions and looking for opportunities to eliminate or to reduce the hazards that may be present to both the environment or to the employees, the workers at your facilities. And don't forget to ask about water and wastewater treatment chemicals as well, because that is a place where those chemicals also are used at facilities. So we did work with Adam at Merrimack Ailes to help him explore options on alternative cleaners and sanitizers. And stemming from that work, we actually sort of took a step back and did an alternatives assessment to look at a set of different cleaner options that could be safer than what was currently being used as baseline cleaners at breweries, and also looked at a set of alternative sanitizing chemicals that could potentially be paired with those new chemicals for cleaning. So there's a full report on our website at turi.org. There's a section on breweries and our work with Adam's video case studies that we've written about the project we did with him, as well as this alternatives assessment that we've completed. I'm just showing you here the final results, so you sort of get to the bottom line without having to read through the whole report. But this shows you the baseline cleaners that we analyzed. The powder keg was what Adam mentioned as their baseline cleaner there, and we compared it with a few other baseline cleaners that are commonly used in the industry. And then we looked at some alternative cleaners, also readily available, an enzymatic cleaner, the ECA that was mentioned, electrochemical activation, where electricity is passed through a salt and water mixture, and then two other ready-made purchasable products called Surface Cleanse 930 and Micro AO7. So you can see the results of the cleaning in the right-hand column there for our testing in the lab. And then what we did was we looked at a suite of alternative sanitizers. So peracetic acid, ECA at a sanitizing level, a lactic acid product, caprylic acid, the NADCC tablets that Adam mentioned using, as well as an ozone system. And we paired each of those with the cleaners. So if you look at LFE enzymatic, for example, and you want to see how that cleaned and then sanitized using the ECA, I think you can see my mouse, you can see our ATP results from our lab testing. So if you wanted to look at how a certain sanitizer pairs with a certain cleaner, you can see from this table. And the idea wasn't to steer you towards any particular product, but help you understand that you can explore these alternatives and potentially get excellent results that are just as good as the baselines that maybe you were using before. Oops. Okay, so we've also done some work with a large soup manufacturer here in Massachusetts, and they were interested in reducing their use of sodium hydroxide that was used at their facility to clean their kettles, clean them in place. The caustic soda, or the NaOH, is classified as a toxic chemical by our Toxic Use Reduction Act here in Massachusetts. So those of you in Massachusetts are familiar with the fact that using certain chemicals over certain thresholds, you need to do reporting and planning and pay fees. Those of you outside Massachusetts don't need to worry about that, but that can be a driver here in Massachusetts to help facilities pinpoint and focus in on certain chemicals they might want to reduce. And also when used in large quantities, it does pose a threat, a hazard to the food, the employees, as well as the environment. So after partnering them with UMass Lowell researchers in the food safety program, they found out that they could actually reduce their concentration to 75% of sodium hydroxide and reduce about 15% of the amount of sodium hydroxide that they used annually. And again, they were able to showcase that the ATP results, the swab that you saw Adam doing in his vat at the end, showed excellent results. So we were not compromising safety or integrity of the product, but reducing chemicals and water use at the same time. They also found through their testing at the university that they could reduce their the temperature at which they were doing the CIP, or the clean in place process, at, thereby reducing their energy bill as well. And Kettle Cuisine is also, that's the soup company we were working with, is also enrolled in a lean manufacturing course that we're currently undertaking through TURI with funding from EPA Region 1. And they're now looking at fine tuning this process even further based on the amount of burn on their edge of their kettle, so that people aren't using the same SOP to clean no matter what the kettle looks like, but changing the amount of chemical based on how much cleaning is needed in the vat. We also worked with another soup company in Lowell called the Plenus Group, and they also were able to identify 2 potential options for changes in their cleaning process, and we're currently helping them to fine tune again those options and look at what might actually work in their facility, because sometimes the lab testing can be different than the field testing or the actual in-field implementation. And they're also enrolled in our lean manufacturing course and are learning ways to reduce their chemical use further, as well as their water use, looking at their process that they're using at the facility. We also have worked with a small mushroom grower here in Massachusetts. The owner was using bleach just to spray down and wash down the walls. She had plastic sheeting on her walls so that her wallboard didn't get wet and moldy from the wet, moist environment that they need for mushroom growing. And so we evaluated safer alternatives, again, ones that Jason mentioned, the steam unit, the electrochemical activation, the NADCC tablets that Adam switched to, as well as a simple vinegar process. And she ended up choosing the ECA. They all worked well enough. And she chose the ECA technology. It's called Force of Nature, which is a simple spray bottle and a tablet to generate the cleaning material. And she chose it because it was ergonomically best for her and worked well and was an economical choice. So we helped steer her away from bleach for that application. We also did a small project with Cape Cod potato chips. They had been using chemicals in a titration system to check their frying oil, to check for free fatty acids that they needed to verify the quality of before doing their frying of the chips. And they identified a new piece of equipment that used photometrics to test the frying oil instead. And by changing out this process, they were able to reduce their chemical use and now simply use this equipment that you can see there that uses a small bit of isopropyl alcohol in their testing. And it reduced employee exposure, reduced the testing time, as well as their costs associated with the use and disposal of the materials. So that's a little highlight on what work we've done with the food and beverage sector. We have other resources available online at turi.org, our education and training materials. We've done several virtual demonstration sites of facilities this year that are available online as video recordings. We have laboratory, as you've heard about, as well as library services. We do a lot of policy analysis related to chemical use that's available online. And for those of you in Massachusetts, we do have grants available, and we do periodically put together peer mentoring work groups around different sectors and different issues. So if you're interested in any of that, please reach out. Our grants, our applications are due for the business and industry grant program on June 25th. So the deadline is getting closer. So if you have any questions, please feel free to reach out.
Thank you so much, Joy. I would love, I know I'm pushing to 2 o'clock because I spent 5 minutes flubbing around with my PowerPoint, but I'd love to hear from some food and beverage folks in terms of their reactions or questions based on some of these presentations. Chris Crowley, can I call on you to ask you for your perspective from years in the business on polar beverages? Would you mind? But you have to unmute. I'm sorry. Could you unmute yourself? Thank you.
I'm sorry about that. Yeah,
That's
we
all
have
right.
a highly experienced workforce, our brand here. But I'm listening just to become, the protagonist, to be able to understand what they do a bit more. We used to have the guy, and we're way beyond that with SQF level 3. standards. We have a great group. And I did look deeply at the electrical, transfer and never felt comfortable with that. We used Oakide for years as our chemical supplier. I think they've been acquired 3 times, but we've got Art, who is in his 80s. He's retiring soon, and he's an outside manager that comes in. He does a really, really good job. He's, one of these guys that's been with us on the outside as a contractor. And we have tremendous results with our counts. We do rinse water counts, and our challenges, I think, are a lot easier because we're dealing with seltzer. We don't have soups and, the solids that a lot of you guys have to deal with. We just don't like using preservatives. We have a very clean label. So you don't want to add, potassium benzoate, potassium sorbate. So it's all about keeping things clean and weekly hot CIP, all of our lines, and we do rinse water counts, I think, daily. We have a good, a good history. We had competitors that tried to use juice. I don't know if any of you are familiar with our Polar Orange Dry, but it's 10% orange juice. And it's the way orange soda used to be made. We make other orange sodas and they have, 50, 60 different ingredients in there. Orange Dry is citric acid, orange juice, orange oil, and a sweetener. We do use a preservative there, potassium benzoate, but that stuff in any other factory was growing, it was like a weed. Plants just didn't have robust enough cleaning processes in place to run that juice through. We're so lucky we have carbon dioxide. So carbon dioxide naturally is a great natural preservative. Our pH of our water is about a 3.2. That would be a neutral pH, 7 pH once you add that carbon dioxide. So it's a great natural preservative. I don't know if you have any questions about what our magic is. I'm just trying to hear from you guys to see if I can give some guidance to our people, because they're working so hard. I mean, we put a new can line in. We put a new can line in 18 months ago, and we just commissioned another line 6 days ago. And it's so nice to see the schedule not running 7 days a week next week. We've been, our guys work so hard, and 7 days a week our guys love the overtime, but 7 days is kind of intolerable. But it's good to see that we're making investments in our plant to make our employees' lives a little bit better.
Thank you so much, Chris. And thank you. Several years ago, you presented at one of our first in-person workshops when we were able to be in person. So thank you.
Good, I recall.
Can I just ask, I have 2 Nicks on the name, on I think Nick Green and Nick Katzos, one from Bacon Joy and the others from Thin and Trim. And I was wondering if you wouldn't mind my calling on either of you, just to add your perspective or questions, if you're still on. Ooh, I should have checked that. Maybe not.
This is Nick Katzos from Thin and Trim. I'm still on. I am not that familiar with all the chemicals we use. We use, foaming products from Du Bois, Ecolab, and, QC kind of handles the SOPs and things like that. I'm more a facility guy.
Mm-hmm.
So that's not my strong point.
Is this helpful to you in terms of being able to ask questions or?
Yeah, I mean, we're looking at ozonated water for disinfecting. Actually, we're looking for it to disinfect some products we're running. But we also, would use it in cleaning. We're always looking to cut down on chemicals. And obviously, I'm not sure how green QC is, but, it's something to bring up. We're SQF, I believe, level 3. We just had our inspection. And, we have to be careful with what we put on our products, they're food products. So, we have a couple different plants, and I think they use some stronger chemicals in our smokehouses, but the plant I run doesn't have any smokehouses. So We don't use that. They have a clean in place system, and I believe that's a caustic.
Thank you.
You're welcome.
Anyone else have a question or would like to share some of their experiences at either their beverage or food company? And if not, if I can, we'll keep going, but I'm going to shut the recording off in about a minute. But again, I want to acknowledge EPA Region 1 for their leadership in this area. And Rob, would you like to say a few words?
Yes, I would love to say a few words and say it with my face. I want to thank Madeline so much for putting together this program. EPA gives the money through its pollution prevention grants to a lot of worthy grant recipients, but it's the work that you guys do to reach out to businesses that need this kind of technical assistance, to look into the science, to bring together the expertise that really helps to change the way that our economy works and the way that business can become more sustainable. So just thank you for making such good use of this public.
Great. I will send the recording, and I will also send you a list of the resources. And and you can definitely share the recording with anybody that you know of. It'd be absolutely great. And again, the first Thursday of each month, the next one will be about organic waste or waste. And that includes solid waste as well as food waste. And then on July 16th, we'll be doing energy, August 20th, water, and September 17th, kind of wrapping it up, talking about results and measuring and communicating success. So I want to thank you all. I am going to shut the recording off, but we can continue the conversation if you have additional questions of Adam, Joy, or Jason, or just between yourselves. So once again, thank you very much. I'm going to stop the recording.